So now we go into the subject matter of macro. So let me just change the setting. So what is a macro? Is actually a group of instructions that are grouped together and assigned a name, something similar to function in C programming. One or more multiple arguments can be an input to a macro. I'll just read out some of the features and then we'll see hands-on how the macro looks like. By entering the macro name, the same group of instruction can be duplicated in any place of the program. Now, when you use macro, what happens? The user program is made more readable by using macros, and user becomes more productive by saving the text entering time. So the macro directive has this format: macro and nm, n macro. So macro has few things that you need to include. You need to assign a name, and then you need to begin with the keyword macro, and then you need to finish it with nm. In between, you can have all your instructions. So let us look at an example. We will refer back to our same example that we did here. So our coding just now is divided into two basic tasks, right? The first task is to load two values into two respective file registers. And the second task is to add. Is that okay? We are referring to the same example. Now what we're going to do is I'm going to replace this whole code with the macro. So you need to define macro, and where do you define macro? Is always before the program start template. So remember the sequence of where we are arranging things. So the hash include always is the top, and then followed by data directives if you have data directives, and will be followed by macro directives if you have macro directive, and then will be followed by program start template, which is with main program, and at the end, if you have, then you include that data directive to store data into program memory. Is that okay? So here we are going to have a macro directive. A macro directive need to have a name. So let's say for the first task, maybe I put the name load. And what is the keyword that I need to start off with? So that macro. And I need to end it with and macro. So this is the structure of a macro. So you need to have a name, you need to start with macro and end macro. So in between is where you sandwich it with the series of instructions. Is that okay? Are you all following? So what I'm going to do now is I'm going to just cut this entire thing here, and I'm going to paste it here. Is that okay? Then this is one macro. So here I'm just going to put NOP. And here, how do we call the macro? Just by typing the name, load. So let's see how it's. Now what happens is, you see, whenever you put here load, it is just, even though you write a macro here, directive, what is it doing is, remember it, what the point is of course it makes more readable and use macro, and by saving the text entering time. But it doesn't, whenever you write load, what happens is that still the content of load, this whole series of instruction, it is stored at this location. So if you see, when you build this, you look at the opcode. You start, you see NOP. After NOP, do you see the same instruction? The loading. So it is just making your main program to look more readable, that's all. So this is the difference between macro and subroutine. Subroutine is a function which we learned in chapter 4. You may seem like same, that one also you're calling. And a subroutine is a separate program like this. And macro also a separate program like this. What is the difference? Macro is just making here seems like very short. As a user, it seems like your program is very short. But what is it doing? It is actually replacing the load with the entire program here. But for subroutine, when you're calling a subroutine, the entire PC is actually, in the main program, you don't see the subroutine's instruction here. You don't see it here. It is actually stored in another location. So, the benefit of it, I'll actually explain later. The benefit of subroutine is that it saves memory space. This one, it doesn't. It uses up memory space. So, one of the effective way of doing programming, whatever that you type in the main program uses up the most memory space. Whatever that you type in the subroutine, what usually the computer will do is it will reuse memory location for every subroutine. Subroutines don't lock the memory locations, but main program do. So sometimes when you're doing embedded programs, what we normally students will do, we will write every single program in the main program. Everything will chuck into the main program, then you see your memory allocations will be a lot. But if you take the main program and you make it into subroutine, you will see that the memory space becomes reduced a lot. So it's one of the efficient way and one of the effective programming techniques that you can opt for. But macro doesn't do that. Macro is just in terms of visually looks like one line only. But in essence, there's a whole set of code which is stored in the main program. So when you execute this, so when you go to this part load, it has not executed. So what it does, when you press again, it seems like it goes to the next one. But what is happening is very quickly it's coming here, is executing all this instruction and going to the or in other words, all this code here are actually here, right? So what is it doing? It is executing all one shot, very fast. So therefore, you can see in the file register, you see the values are already there. And then this one you'll be doing, you'll go one by one. Then end. So can we also make this into macro? Can. So you can have as many macros as you want. So let's say the next macro is add. So what is the format? Macro and macro. And what do you do here? Oops, sorry. I didn't copy, just not do it. So you can copy the entire thing. And here you can call the name and then just put here NOP so that you can see where's the green arrow. So it seems like now your main program looks very, very short. But is the main program different from what we have actually written just now? In essence, in program memory is the same. The entire set of code are there. Just that in terms of programming here, it looks like very, very short. Make it more readable. So you can see in the main program, nothing changed. It's all the same thing. Is there? The only thing is, when you go to the load, oh sorry, I'm pressing the wrong button. Load, it'll execute all the load at one shot. Add, it will execute all the add in one shot. Is that okay? Now, What is the issue that you think is with this particular macro? You can debug. You can still debug. Well, what is the very apparent thing? It's not a problem actually. It's just a issue. What? Yes? No, I assume there's no error. There's no error. What is the? Okay, return value coming close. Something related to that. Can you use this load macro to load any other value? This specific macro. Can you use this specific macro to load different value to different location? Currently, no. The issue here is each one of these macro. Of course, the macro you can actually call how many times you want, so you can repeat. But what is the issue here? It's very specific, right? This load will only load this value to this specific address and will load only this specific value to this specific address. Now, if you want to load some different value, you can't use this macro. So that is the limitation here. So if you want to make your macros more dynamic, there could be two types of macro. One macro, yeah, you know that specifically you're not going to change anything. So you can call that kind of macro. But let's say in this kind of loading type of macro, you want to load different values now. Okay, assuming that you want to keep those addresses same, hex 10, hex 20, store at 30. But now you want to try with different values. Can you still use this macro? You can't, because it's fixed. You can't change. So that's where the second type of macro comes in. Macros with input arguments. It accepts input arguments. So the second set of macro, now you see the macro, there's no input argument here at all. So the first thing is, let us see how we can actually try to solve this. Assuming that we only want to change these two values now. So the code remains the same, right? Move LW, move WF, move LW, move WF. Out of all this, which one do you think will be our variable? Value 1 and value 2, very good. These two will be our variable, which means we want to have num1 and num2 fixed. We still want to store at hex 10 and hex 20. But we want to make val1 and val2 as our variables. So how many variables do we need now? 2. So what happens? You can define here. Now you can give whatever names that you want. Huh? So I'm just going to put variable 1, variable 2. You can give whatever name that you want. I notice that sometimes when I give the liberty for students to give any names, they tend to give animal names. And the most popular animals are ayam and ite. Chicken and also the duck, I do not know why. Maybe they're quite hungry that time, not so sure. But try to keep the naming convention to something which is relevant. But here you can give whatever names that you want. It can be a single letter, can be multiple, whatever it is. You can give whatever names that you want. Okay, this is you are defining it. Now the comma defines how many variables that you want to accept. So this is only 2. So variable 1, comma, variable 2. So you know that it is expecting 2 values. Now you have given this variable and variable 2 names, right? You have to use them here. So where do we want to use them? So instead of value 1, I'm going to put variable 1 and 2. Is that clear? This name convention, whatever that you have named, you must be using it here. Is that okay? Yes. Okay, coming to that point. How do we know which value is variable 1 and variable 2? Now you can set, let's say I just putting here variable 1 and variable 2. In the load here, the sequence that you type here determines which value goes to which variable. So let's say now we are having this val1, val2, right? So if I put val2 first and then val1, what is value 2? Value 2 is 55 and value 1 is 33. Because I arranged to send value like this, the value 2 will be passed to variable 1. So what will be variable 1 here? 55 and variable 2 will be 33. Take note that the names here are not necessary to be same as this one. Is that okay? Whatever naming convention that you give after the macro here, you must use it inside that macro. Understand? Here you can pass whatever value that you want, and the sequence will determine which value will pass to which variable. It follows the sequence. So if you do something like this, load value 2 to value 1, so if you execute this, and let us look at the file register. Okay, now look at this. We're going to load. Do you see now it's 5533? Because you have sent it in this sequence. If you do like this, you're sending 33 and 55. So let's see, is it correct? Now all this, how do you know whether it's working or not? By you trying in MPLAB. Only by doing you can actually try to learn. After all, this is a programming language. So now see, it's 3355. Is it understood? Now let's say I want to reuse back the same macro. Give another two values. Any value? X 31. The next one? Value 2. So you can even send like this. So hex 31 will be passed to variable 1, hex 32 will be passed to variable 2, and accordingly it will substitute the values here. So let's do this. So the first one, it loads 33 and 55. There is no, the color doesn't change because it's the same value. In the file register, only when there's a change of value, it will turn red. Let's see this one. You see it loads 31, 32. But you're using the same macro, right? So now you have made the macro more dynamic. You can explore further to make this also variable. So you can add on. Put variable 3, variable 4. Then you can put here variable 3 and variable 4. Now you made all variable, which means you can choose any two numbers to store any two address. But remember the sequence. The sequence here is what? The first two is numbers, the last two are address, location. So now this one will be like num1, num2 is what you send the first one. But here, let's say if I'm going to choose 12 and 22. 12 and 22. Which means I can see the answers, the value loaded in these two locations. Right? This is 12 and this is 22. So let's see. say now it loads 3355. I'm going to use the same macro again, but I'm going to load 3132 into 12 and 22. You see the effect? Is that okay? Now that is how you do the same thing. You can actually apply for the addition as well.